This is Andrew Humble, and this is my final project demonstration for the 1730 final, which was at least 4, possibly more, Project Euler questions. I did 6, 4 from the project description and 2 from the Project Euler site. I have more details about what each of those are and how to run them in the README file. And so, challenge A, an array of zeros, takes in an array and moves the 0 elements to the end. Index, which finds an element whose value at an index matches the index itself. Even odd partition, which takes in an array, moves the even numbers to the left, odd numbers to the right. Zero sum takes in an array and finds 4 integers that sum to 0. And then even Fibonacci numbers finds the sum of all even Fibonacci numbers from 2 to 4 million. And the special Pythagorean theorem finds a triplet that satisfies these conditions right here, and then it computes the product of all 3 of those. So for each of these from the project description, which would be A, B, D, and F, you can either run them with no input arguments, so just kind of use whatever array is hard-coded in, because they all need to be given an array. And so here, hard-code in 502401, and the output is the same array, just with the zeros at the end. You can also give it a input argument in this kind of format right here, just the file as its input argument. And you'll see it as the same thing, moves 0 to the end. We can look at B. And so hard-coded in is this. You'll see that at 0, 1, 2, 3, the element at 3 matches its index. Do the same thing with an input argument. You see it matches there. And even if let's say we want to change that test file and make that 1. And one other condition of this is that the integers do need to be in increasing order. So we can replace that 2 with a 1. It will still satisfy it. And then we can do same thing. And we'll say there's no element whose value matches its index, which is the correct output. Then do F. We can then do D. And D is the one that I did in C. So it's the only one in C. The rest are in C++. It takes in an array of numbers and moves evens to the left, odds to the right, as mentioned before. And do the same thing with the test file. And there again, evens to the left, odds to the right. Then clear the screen, and we can do F now. And this is the 0 sum, so given this, it finds elements 2, 2, -1, and -3, and those sum to 0. Or we could change the test input and say -3, -1, 1, 2, 1, and 5. I think that would work. And then we could run it with that input argument. And yeah, it would find -3, -1, 1, and 5, which all sum to 0. Perfect. And then we can do FP Euler 002. And this, not really any inputs to give here because it's just computing some solution. And so it takes in all of the even Fibonacci numbers and has summed them to, looks like 4,613,732. And then for my last one, 009, it takes in a Pythagorean triplet that satisfies all of these conditions. And those conditions are A needs to be less than B, which is less than C, and then needs to satisfy the Pythagorean theorem, A squared plus B squared equals C squared, and then all 3, A plus B plus C, must add up to 1,000. You see the solution down here. We prove each of those, and 200 is less than 375, which is less than 425, and then multiplying those together gives you this 31,875,000 output. So yeah, that's my 6 demos for my 6 exercises I did, 2 extra for my 1730 Project Euler final. Thank you.